Hey guys, so in this video we're going to review rounding with significant figures, or Sig Figs. This topic is one of the ones that you need to master in order to be successful in all of the other units in chemistry. So the first thing you need to ask yourself when you see a decimal is the decimal absent or is it present? If the decimal is present, you're going to start counting from the Pacific side. If you're picturing the United States, you're going to count toward the right from the first non-zero digit. If the decimal is absent, you're going to count from the Atlantic side, and you're going to count toward the left from the first non-zero digit. So let's look at the rules for multiplying and dividing with significant figures. So the first thing you need to do is determine the number of sig figs of each individual piece, and then you're going to round your answer to the least number of significant figures. So in this example, we have 23.7 times 3.8. Again, we need to look at each individual piece and determine how many significant figures each piece has. So the 23.7 has 3 sig figs and 3.8 has 2 sig figs. So when we go into our calculator, we get 90.06, but again, we need to round this to 2 significant figures because that is the least number of sig figs in our overall expression, and this is what we'll receive as our answer. Okay. In the next section, we need to remember the rules for adding and subtracting. So the first thing is we need to do a little recap on rounding. So in this decimal, we have before the decimal place is called your ones place. Anything after the decimal place would end in THS. So our first decimal place is the tenths spot. Then we have the hundredth spot and thousandth spot and so on. So our rules for adding and subtracting, we need to determine the least precise decimal place of each piece. And then once we determine that, we're going to round our answer to that least precise decimal place. So in this example, we just need to take a look at the least precise decimal place. So our first number is rounded to the tenth spot. Our second number is rounded to the 10,000th spot because there are 4 decimal places. And our last one is rounded to the 100th spot because there are 2 decimal places. So if we type this into our calculator, we receive this decimal. And again, we need to round to the least precise decimal place. So the least precise decimal place would be to the 10th spot. So our answer would be 2026.8. Okay, why don't you pause the video here, try out this example, and we'll take a look at our rounding with sig figs. Okay, it says using a triple beam balance in a graduated cylinder, a student collected data on a sample of an element. Calculate the density of the sample, and then based on reference table S, what element might the sample be? So there are 2 parts to this question. If you notice, they give us all of the information that we need below. The mass of the sample is 10.9 grams. The volume of the water is 30 milliliters, and the volume of the water and sample is 34 milliliters. Okay, so the first thing we need to do is calculate the density, and we can find our density formula on the back of our reference table, and we have density is equal to mass over volume. So if we go into the information that they provide us, they give us the mass is 10.9. Now, they want the density of the sample, which means we need to look at the volume of the sample. If you notice, they give us 2 volumes. They have the volume of the water and the volume of the water in the sample. To determine the volume of the sample, we need to subtract those 2 values. So we have our mass is 10.9 grams, and again, we're subtracting the volume of the water and sample, which is 34.0 milliliters, and we're going to subtract that by the volume of the water, which is 30 milliliters. When we go into our calculator, we get 4.0 milliliters. Again, we were subtracting there, so we use the least precise decimal place. Both of the values in the denominator, we're using the 10th spot. So when we rounded, we needed to have the 10th spot. You need to have that 0.0 there. Now we're going to use division, and division is the least number of significant figures. So if we take a look, we have to type into our calculator. We get 2.725. But the least number of significant figures is 2 significant figures, and that's being used in our denominator. So if we round appropriately, we get 2.7 grams per milliliter. Now the last part of this question asked us to determine what element this sample could be. So if we go to scary table S, we're going to compare and we're going to match our density. We're going to find a density of 2.7 grams per milliliter. And in table S, we would see that that element is aluminum.